Okay, so we are starting with Algebra Review Day number 1. Make sure you have this open and sent to Notability so that if I say pause the video, try this problem, you can. Or if you want to just try, like, for example, hey, I think I know how to do examples 1, A, B, and C. Try them on your own and then you can just compare answers. Another way of doing that is trying them on your own and looking at the answer key. Okay, so each of these is linear functions. They're all in 3 different forms. This first form here is slope-intercept form. This is point-slope form. And this is standard form. So let's start with the first one here. Slope-intercept form. Making sure we remember how to do this because you have to graph lines all the time. And we're not going to remind you how to graph lines only this one time. So you need the y-intercept, which is 0, -2. Because this -2 right here, so graph that point. And then you need the slope, which is 1/3. So it's rise over run, so you're gonna go up 1, right 3, up 1, right 3. You could also go back to that first point and go down 1, left 3, because 1/3 is the same thing as -1 over -3, right? Down 1, left 3, and then go ahead and connect those points, arrows on the end. All right, this is point-slope form. Point-slope form is in the form y minus y1 equals m times x minus x1, where x1, y1 is the first thing that you're going to graph. It's the point, and then you're going to use the slope, okay? So remember, this is x1. It's the opposite of that due to this net minus right here, so -5. Opposite of that, so +2, okay? Or I should be saying it's a minus in the formula. It's a minus here, so it's 2. It's a minus in the formula. It's a plus here, so this is a minus negative, so it's -5. See how that works? Okay, graph the point, -5, 2. And then now you're going to use your slope, -1/2. So -1/2 can be written 3 ways, like this. That says -1/2. This says -1/2. And this says -1/2. This one right here is ugly, but it technically says -1/2. So from that point, you can go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, oops, down 1, right 2, and keep going so you can have as many points as possible. And then you can also go up 1, left 2. Connect your points. And there's your line. Okay, this next one is not only in standard form, but it is also a linear inequality versus an equation. Okay, also notice that you can tell that all of these are linear because there's an x and a y. This is technically a y right here, and there are no exponents, right? So we can tell that that's what it is. So I'm not confused in saying, oh, is that a quadratic? Definitely not. There's no x squared in it. Okay, so graphing this, the easiest ways you could solve for y, but then you have to remember are all of your properties. I'll show you that last just to make sure. Instead, what we use is the cover-up method, okay? The cover-up method, what you're actually doing is you're going to end up finding your x and y intercept, okay? So you're going to plug in 0 for y and see what you get for x, and then plug in 0 for x and see what you get for y. The reason it's called the cover-up method is because if I plug in 0 for y right here, it's like covering it up, right? And then you solve that as an equation. 2x equals 12, so x equals 6. So the x-intercept is 6, 0. Now you can do the same thing to find the y-intercept. You're going to plug in 0 for x and see what you get for y. If you plug in 0 for x, this is gone. Solve that. If it was an equation, you get -4. Now you can graph those 2 points, 6, 0, and 0, -4. And now, since this is an inequality, you have to look at the inequality symbol to see if it is solid, which includes the points, or dashed, which means you don't include the points. So since this is greater than or equal to, it's including those points that are on that line. So you're going to do a solid line here. Now, also since it's an inequality, it's not just those points, it's values that are greater than that 12 right there. So I need to know what side of this line that I'm shading on, what points are greater than, okay? So how I'm going to do this is that I like to pick a point anywhere that I want. So I'm going to pick 0, 0 right here, okay? I'm going to have to erase that when I'm done. I'm going to plug 0, 0 into the original here. So if I plug in 0 here and here, okay, so I get 2 times 0, which is 0, minus 3 times 0, which is 0. So I get 0 on that side is greater than or equal to 12. Is 0 greater than or equal to 12? No. That means that 0, 0 is not a solution. Okay, so nothing on that side of the line is a solution. All my solutions are on the other side of the line. So my solutions are on this side of the line. I'm also going to erase that to say that 0, 0 is not included in my answer. Okay. Next we have write an equation of a line that passes through the point, negative 2, 3, with a slope of 1/2 in point slope form and also slope intercept form. So 99% of the time we're allowed to keep it in point slope form, which is good news because it's the easiest. Okay? To write in point slope form, you need a point and you need the slope. I should go like that. There we go. All right, so point slope form, as reminders right here. So you can bring this down here just so you can see it. I brought all my circles, but big deal. But what you're going to do is that this is x1, this is y1, and this is m, your slope. So you're doing y minus y1, which is 3, equals m, which is 1/2, times the quantity of x minus x1, which is a negative 2, minus the negative turns into a positive 2. Slope intercept form is y equals mx plus b. So if you look, it's y is by itself. So in this equation here, I have to get y by itself. So to get y by itself, I'm going to distribute the 1/2. Right? So I'll write this off to the side over here and change colors. So that's y minus 3 equals distributing the 1/2, 1/2 times x, 1/2 x, 1/2 times 2, so half of 2 is 1. We do a lot of no calculator. This is all stuff on this we would expect you to do without a calculator. Add 3 to both sides, and you get y equals 1/2 x plus 4. Okay? Okay, let's move on to the next problem. Write an equation of a line that passes through these 2 points. So once again, I'm going to ask you this countless amount of times, or your teacher will ask you this countless amount of times throughout the year. What do you need to write an equation of a line? You need 2 things. You need a point, and you need the slope. Did we give you a point here? Yes, we gave you 2 points, so it doesn't matter which one you use. Did we give you the slope? No. So now I have to make sure I know slope formula. As a reminder, slope formula, what you have to know today, tomorrow, 6 weeks from now, on your second semester final exam. This is something that you're going to see in everyday problems where we're not telling you like, oh yeah, this is how you find slope. Make sure you know slope formula. Make sure you know point slope formula. Make sure you know slope intercept form. Slope formula is y2 minus y1 over x2 minus x1. All right, so let's find the slope of this line. So we have y2, which is 4, minus y1, which is 3, over x2, which is 1, minus x1, which is a negative 2. Since it's a double negative, I'm going to turn it into plus. 4 minus 3 is 1. 1 plus 2 is 3. So now I know the slope is 1/3. Now that I know the slope is 1/3, I have a point, I have the slope, I can write my equation. Yes, I could use this point also, but I'm just going to use the first one. Y minus y1, which is 3, equals m, 1/3. X minus x1, which is a negative 2, so double negative turns to plus. There's my answer. Okay, now if you're like, wait, why didn't I put it in slope intercept form? It's because it said write an equation of the line. This is an equation of a line. Why would I go any further, right? It's more work. All right, next one, solve the system algebraically. Okay, so this is a system because it's 2 equations with two variables. To solve a system of equation with two equations and two variables, you can use substitution, elimination, graphing, or matrices. Since this is all no calculator, we're going to go away from matrices. Since we're given graph paper, not using that. The question is should I use substitution or elimination? Okay, so here's when you use substitution. You use substitution when you already have a variable solved for, meaning one of the equations is x equals or y equals. That's not happening here. So what I'm going to use instead is elimination. I'm going to try to get one of my variables to eliminate. So I'm going to look to see if I add them right now, does anything cancel out? No. And I mean, does x or y cancel out? So no. So I have to manipulate this so x's or y's will cancel out. Well, I see that this is a negative 2y. I can multiply this second equation by 2 and it'll become a positive 2y. Then it'll cancel. So that's what I'm going to do. My first equation is going to stay the same. My second equation, I'm going to distribute it 2, 2. 4x plus 2y equals 8. Now I can combine these. So this method is not just called elimination, it's also called linear combination because you're combining lines. 7x, these cancel, equals 7. Divide by 7, x equals 1. Now I have x, I need y. So I'm going to plug in x into either of my original equations. It doesn't matter which one. I'm going to use the first one though. 3 times 1 minus 2y equals negative 1. 3 minus 2y equals negative 1. Subtract 3. Negative 2y equals negative 4. Y equals positive 2. So my answer is the point 1, 2. Please realize that this is a line. This is a line. I'm solving the system means that I'm finding their intersection. This is where they intersect. You could always check your answer by plugging 1, 2 back into the equation. Okay, next we will be talking about quadratic and polynomial functions and equations. Okay, so factoring. When factoring, there's multiple steps that you could say to yourself in your head before you start that you have to go through. The first thing you should always ask yourself is there a GCF? If there's a GCF, then you need to pull it out, okay? And when I say pull it out, I mean like you're factoring it out of those terms, but it's not going anywhere. It's not like you're dividing it out and it disappears, okay? All right, so let's start this one here. Is there a GCF? Is there anything that all three of these terms have in common? The answer is yes, it is A. So I'm going to factor out the A out of each term. If I factor an A out of A cubed, there's A squared left. Here there's 8A, and here there's 12. Now notice it says factor completely. So now I have to look to see if what I have left is factorable. If there's three terms, you are going to see if it's factorable. Okay, now a lot of you are taught this method, this X here, where you're looking for two numbers that multiply to give you, and you're looking at the coefficient right here, which is 1, times this number right here is 12. And they have to add to give you your middle term, which is 8, your B term. All right, so factors of 12 that multiply to give me 12 and add to give me 8, which are 6 and 2. Then remember you have to divide by the lead coefficient. The coefficient is this number right here, which is a 1. So divide both of these by 1. And then you can write your, if it's simplifiable, if either of these are simplifiable, you need to simplify them. But 6 over 1 and 2 over 1 is not simplifiable. So remember, this is your A term, and this is your A term here. So this is A plus 6. And this is A plus 2. Now you might not have learned how to factor like this. You might have learned to factor by grouping. You might have learned to factor using some other method, like a box method, maybe. But you can factor any way you want. As long as you have the answer I have, then it's correct. This is also acceptable as an answer. This is the only other acceptable answer because it's equivalent. Okay, next one. I need to factor this. First thing I need to look for is a GCF. Okay, so is there a greatest common factor? No, they have nothing. 9 and 49 have nothing in common, and these are all x's and these are all y's. So now, since it's 2 terms, right? This was 3 terms. 1, 2, 3. Since it's 2 terms, what you're going to do is you're going to check to see if it's a difference of squares. So you're asking yourself is this a perfect square? Yes. 9 is the same thing as 3 squared. Is this a perfect square? Yes. X to the 4th is the same thing as x squared squared. 7 squared, y squared. So yes, it's a difference of squares because all those are perfect squares and it's a difference. So I can factor this now. For a difference of squares, it's going to factor to 2 binomials. And I'm looking for this first term here. Now these 2 terms have to multiply to give me 9x to the 4th, and they have to be the exact same thing. So that's 3x squared and 3x squared. Okay? These next 2 terms, the last 2 terms, have to multiply to give me this. And they have to be the exact same thing. 7y and 7y. Okay? Now I just need my signs, right? There is no middle term. There is no third term that's in the middle. So that means that these 2 terms have to be opposites because they have to cancel each other out. So one's plus, one's minus. That's going to make my inner and outer term cancel. So that's how you factor difference of squares. You need to check to see if either of these are still factorable. Okay, it's 2. There is no GCF. It's 2 terms, but it's not a difference of squares. Same thing here. It's a difference, but it's not a difference of perfect squares. 3 is not a perfect square. So this is done, and this is your final answer. Okay, next one. There's 3 terms. First thing I look for is a GCF. All 3 terms, 1, 2, 3, don't have anything in common, so no GCF. Since there's 3 terms, once again, I'm going to use this little organizational x here. I'm going to do a, which is the coefficient in front of this, which is 1, times c, which is negative 35. So 1 times negative 30 is negative 35. And b terms negative 2. I'm looking for factors. 7 times 5 is negative 35. I'd have to make the 7 negative. Divide by the lead coefficient, which is 1. I'm going to erase that now so it's not there anymore. Remember, this is your x term, x term. Now notice, when I go to write these down here, these 2 terms still have to multiply to give me this. X times x is not that, so this has to be an x squared and an x squared. So x squared minus 7, x squared plus 5. All right, now I got to look at these. No GCF on this first binomial. All right, there's nothing that they have in common. But is it still factorial? So is it a difference of squares? It's a difference. X squared is a perfect square. Is 7 a perfect square? No. So that's not factorable. Look here. It's not a difference. So this one's done. All right, next one here. Is there a GCF? 1, 2, 3 terms, nothing in common. No GCF. So I'm going to use my little x to help me factor it. Now, once again, if you have a different way of factoring, guess and check, breaking up the middle term, you can factor any way that you were taught in the past. I'm just showing you the way that most of us, I shouldn't say most of us, but a lot of us factor. Okay, so once again, you have to do A times C. A, C, which is 6. Middle term, which is your B term, 7. All right, I'm looking for 2 numbers that multiply to give me 6 and add to give me 7, which are 6 and 1. Do not forget to divide by the leading coefficient, which this time is 2. Okay? So this is the first time this has happened. It's been 1 every time that we've done it so far. So now it's 2. Now if you look, you're going to see if either one of these fractions is simplifiable. The first fraction is simplifiable. It simplifies to 3 over 1. Well, 3 over 1. So it's going to become 3 over 1. And then once again, this is your x term and this is your x term. Look to make sure that it's x times x gives you x squared, which is right. And you can write your 2 binomials. That's x plus 3. That's from this. X plus 3. And this one's 2x plus 1. Okay? You could have also used guess and check where you said, all right, these two have to multiply to give me 2x, and x. These two have to multiply to give me 3. So I could have guessed 3 and 1. And then checked to see if outer and inner give me 7. That's 3x, that's 2x. Nope, that doesn't work. That's 5x. I can try 1 and 3 instead. That's x and 6x, which is 7x. That's my answer. So guess and check always works, but some of us want a method rather than guessing, right? Okay, last but not least, we have solving. Okay, so all of these, let me look here. Yes, all of them are quadratics, right? X squared, x squared, x squared, x squared, x squared. So they're all quadratics. So when you have a quadratic, you should be asking yourself questions. If you can just look at it and know what to do, that's way better. But if you are struggling a little bit, you need to ask yourself questions. First thing is can I solve by square rooting? You can solve by square rooting if there's just an x squared and there is no x. So if you look at this one here, there's an x squared and an x. I cannot solve this one by square rooting, okay? But if you look at this first one here, there's an x squared, no x, you can solve that by square rooting, okay? So let's start by saying that if we get to a no, then we'll say what to do next. Okay, so can I solve by square rooting? Yes, because there's just an x squared, but it has to be by itself. So subtract 3 from both sides. X squared equals -9. I need to get x by itself. It's a square right now. So to get rid of a square, I square root. But what I have to do is I have to remember to account for the positive and negative answers. Okay? Reason why is because I have to be able to plug a number in here, right? And let's say I just give one answer, 2, right? 2 squared is 4, but -2 squared, -2 in parentheses squared, -2 times -2 is also 4. So we have to account for both of those answers. So I get x equals, get back to this, x equals positive or negative, and then I need to know what the square root of -9 is. So first off, what's the square root of 9? 3, right? But it's -9. So you're asking yourself what's the square root of a negative number, and that's I, right? So it's plus or minus 3i. You have two answers, positive 3i, negative 3i. All right, next one. Can I solve square rooting? Yes. There's only an x squared, so I need to add 8 to both sides. X squared equals 8. Square root to solve. I have x equals plus or minus, and then the square root of 8 is simplifiable, right? The biggest perfect square that goes in there is 4, and it goes there twice. So your answer is 2 root 2. As a reminder, you do have to know how to do all of this algebra stuff without a calculator. As we move forward, we'll tell you what you can use a calculator for, but what you can use a calculator for is graphing things. Nothing that is, mental math that you should be doing in your head. All right, next one. Can I solve by square rooting? Here's my x squared. Is there an x also anywhere? No. So therefore, you can still solve by square rooting. You just have to get it by itself. Okay, so I want to solve by square rooting, so I want a square root. Can I square root right now? No, because of this plus 3. So first thing I'm going to do is get rid of that 3. Now I can get rid of the square by square rooting. Don't forget plus or minus. So I have x minus 1 equals plus or minus, the square root of 4 is 2. And now I'm going to add 1 to both sides. So I have 1 plus or minus 2. I'm not going to leave my answer like this because I know what 1 plus 2 is, and I know what 1 minus 2 is. 1 plus 2 is 3. 1 minus 2 is -1. And there are my two answers. Okay, let's move on to the next one. All right, there's an x squared. Can I solve by square rooting? No, because there's an x also. So if you cannot solve by square rooting, you want to try to solve by factoring. In order to solve by factoring, it has to be equal to 0. This is not equal to 0 right now, so I'm going to get it to equal to 0 by adding 20 to both sides. X squared plus 9x plus 20 is equal to 0. So now I'm going to try to solve it by factoring. Is there a GCF? No. How many terms are there? 3. So I'm going to use my little X to organize my thoughts here. A times C, that's 1 times 20, which is 20. B, 9. Two numbers that multiply to give me 20 and add to give me 9, 5 and 4. Look at your lead coefficient, which is once again 1. Divide both of those terms by 1. Remember, this is my x term and my x term. Notice they have to multiply to give me x squared. They do. So my first binomial is x plus 5. My second binomial is x plus 4. And then I still have equals 0. All right, so you're not done here because the directions said solve. All right? It didn't say, hey, this is not an equation, just factor it. This is solve. So now I have to set each factor equal to 0 and solve. So you get two answers, x equals -5 and x equals -4. All right, last one. Can I solve by square rooting? No. There's an x squared and an x. All right, so now I'm going to try to factor it. Is there a GCF? No. All right, now I'm going to use my organizational diamond. 1 times -1 is -1. B is 6. All right, two numbers that multiply to give me -1 and add to give me 6. This one's not factorable. If it's not factorable, you then have to say, what's my last resort? Your last resort is quadratic formula. Okay, yes, you do have to know the quadratic formula. If you need to solve an equation in chapter 3, chapter 4, chapter 2, and it's not factorable, you're going to need to say, oh, that's a quadratic. I guess I'll just use the quadratic formula since it's not factorable. Okay? So to remind you, quadratic formula, I'll write it down. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Where this coefficient, a is 1, b is 6, and c is -1. And now I'm going to import those numbers into this equation. So I have x equals the opposite of b, so -6 plus or minus the square root of. I always put b in parentheses, a in parentheses, and c in parentheses. So b is 6, close the parentheses, square it, minus 4 times a, which is 1, times c, which is -1, all over. Notice where my fraction bar goes from. It goes from the -6 all the way to the end of the square root, 2 times a, which was 1. Now I'm going to clean this up, okay? So to clean this up, I'm going to do this first. So I have x equals -6 plus or minus the square root of 6 squared is 36. The next thing I'm going to do to clean this up, I'm going to multiply these three numbers right here. -4 times 1 times -1. +4. All over. Next thing I'm going to do to clean it up, 2 times 1. I didn't mean to scratch that out, but it's not a big deal. So 2 times 1, which is 2. Okay. Next thing I have to do to clean this up, add those. I need to combine them. Sometimes it's subtraction. So for example, if this was a positive one instead, it'd be subtraction, right? You just have to pay attention. So that's -6 plus or minus the square root of 40 all over 2. Next thing you have to do is simplify the square root of 40. If it's not simplifiable, then you just move on to your last step. But if it is simplifiable, you have to simplify it. Root 40 is simplifiable without a calculator. What is the biggest perfect square that goes into 40? If you're having a hard time understanding what I'm asking you, what are your perfect squares? 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. These we expect you to have memorized, okay? And then now I need to know the biggest one that goes into 40, okay? So all of these are out, right, for sure. Does 25 go into 40? No. Does 16 go into 40? No. Does 9 go into 40? No. 4 does. So 4 goes in there 10 times. So now I have x equals -6 plus or minus. The square root of 4 is 2, so 2 root 10 divided by 2. And I'm on to my very last step, which is dividing. Divide -6 by 2. -6 divided by 2 is -3 plus or minus. Divide 2 root 10 by 2. 2 root 10 divided by 2, root 10. And there's my final answer. All right, so there's your first algebra review. This should have been stuff that was covered in the summer packet, so it shouldn't be any shock to you of what's in here. You can now move on to the day one practice that you're supposed to do, okay? Don't forget that just because it's called day one just does not mean this is the only thing we're doing day one. So make sure that you go back to the Zoom and find out after you're done with your homework your next step.